array processor is a special type of computer processor designed to handle large sets of data called arrays. This is done very quickly by performing the same operation on many data items at the same time. This is different from a regular processor, which usually works on one piece of data at a time. To understand how an array processor works, imagine you have a long list of numbers and you want to add 5 to each number. A regular processor would go through the list one by one, add 5 to the first number, then to the second, and so on. An array processor, on the other hand, can add 5 to all the numbers in the list at the same time. This is possible because an array processor has many smaller processing units, called processing elements or PEs, that work together in parallel. Each PE handles a different piece of data, but all of them follow the same instruction at the same time. To make this concept clearer, think of an array processor like a classroom with many students, where the students represent the PEs. The teacher, acting as the control unit, gives a single instruction: add 5 to your number. Every student has a different number written on their paper, which represents the data, and all students add 5 to their number at the same time. This is much faster than having one student do all the work alone. Array processors use a method called single instruction, multiple data, SIMD. This means one instruction is given, but it is applied to many data points at once. The main advantage of this approach is speed, as many operations happen at the same time, making array processors ideal for tasks like image processing, scientific calculations, and graphics. There is a central control unit that sends instructions to all the PEs. Each PE has its own small memory and can perform calculations independently, but all follow the same instruction at the same time. There are several examples of array processors in real life. Graphics cards, or GPUs, use array processors to quickly process millions of pixels at once, changing colors, brightness, or applying effects when you play a video game. Early supercomputers, such as the Cray machines, used array processors to perform scientific simulations and weather forecasts much faster than regular computers. In image processing, if you want to make all red pixels in a photo blue, an array processor can change all the red pixels at the same time, instead of one by one. A simple diagram of an array processor would show a control unit at the top, connected to a row of processing elements, which are then connected to a memory interface. Each PE is a processing element that works on a different piece of data at the same time. However, array processors are best when the same operation needs to be done on lots of data at once. If each piece of data needs a different operation, or if the data depends on each other, array processors are less efficient. In summary, an array processor is like having a team of workers all doing the same job on different items at once, making it much faster for certain tasks compared to a single worker doing everything alone.